Good afternoon. I am Liu Boyang, Institute of Low Altitude Economics, Xi'an University of Posts and Telecommunications. Our research institute is mainly engaged in the acquisition and processing of space signals and the research in some fields related to low-altitude economy. This is the lab at the institute. The report I made today mainly introduces some applications of USRP in our scientific research work. I mainly divide it into several directions. One is the general direction of application. The first direction is the USRP application, data collection. Because we do a lot of theoretical research, especially university teachers. A lot of what we do is purely algorithmic, including purely theoretical. Some skills and knowledge related to engineering are generally lacking. Suppose some of our algorithms require some data collection in space. And once the spatial data is captured easily, we have to do it with some development boards or some hardware. At present, some open-source development boards. In fact, something like this is an open-source development board for Punctuality Atomic. His problem is that the development software is ArcThread and other software. We came up to him to develop FPGA, which requires some very professional knowledge. Especially the knowledge of hardware is relatively high. The teacher must not have time to do this kind of work. Then we urgently need to collect the space signal now, or we urgently need to verify the signal in space and in the actual environment. What should we do? Then USRP is a very good choice. Because of USRP, its ecosystem has been very perfect. We can develop it with software that we are familiar with. For example, we can use MATLAB, Simulink, LabVIEW, or GNU Radio to directly develop USRP. That is, we don't need to care about how the signal is in space or how it is processed in the hardware. What we care about is how our signal is generated. How do we generate our IQ data? And data collection in space has transformed the baseband. Then how to deal with this IQ data and baseband data after they come up? This aspect has greatly saved our development time. Then MATLAB is familiar to everyone. LabVIEW is actually a bit like MATLAB. It is also a graphical programming language. And GNU Radio. GNU Radio, it's pure open source. There are many tutorials currently. LUOWAVE company has also published a lot of tutorials. Including our own lab, we actually published a few books on GNU Radio based on our previous experience. Everyone can go to the follow-up to refer to it. Then another application direction of USRP is data collection. We picked out 3 typical articles. But the article is much more than that. There are many. The third article is that the Zhejiang University team collected radio frequency data from many drones on the market. So they created a dataset using USRP. Because you know that many algorithms we do, including many algorithms such as deep learning, require an open source dataset. So USRP combined with this drone, we provide a very good ULOV or USRP drone dataset. Then we can do our deep learning or drone monitoring, drone countermeasures, drone recognition, etc. based on this dataset. Then this dataset should be open sourced in 2024. You can refer to it. Then the second direction is signal generation. If USRP makes this receiver in the actual system, the receiving algorithm, so we need transmitters. However, in many cases, due to space and time constraints, we have no way to obtain the actual transmitter signal. For example, if we do satellite reception. So you'd have to buy a satellite pan, and you'd have to count the pans against it, and you only have 10 minutes a day to collect. So this situation poses a great challenge to some verification of the algorithm. And the USRP is uniquely suited for that. For example, some acquisition or demodulation of DVB-S and DVB-S2 signals. Then inside USRP it provides a full set of DVB-S and DVB-S2 protocols. We can use USRP to generate DVB-S and DVB-S2 signals and send it out. After it gets out, we'll take it in another USRP. After accepting it, you can directly go to our MATLAB, LabVIEW, or NeuRadio to process and verify the performance of our algorithm. Very convenient, without actually docking with the satellite. And we can verify it 24 hours a day. So it's very convenient. Then another direction is algorithmic verification. We had a feeling when we were doing theoretical research. Many times experts question our experimental results. So far, the simulation results are provided. So what's the performance like in terms of actual performance? Then we are very distressed. So what we need to do is to validate our signals and validate our algorithms in space. That's when USRP is particularly suitable. Because we've done a lot of work, we're already generating an IQ data. But after the IQ data, we are not familiar with the hardware part. We are all familiar with the previous work of IQ data. So what about USRP? It's a perfect connection with us. So let's just generate IQ data. Then the USRP is responsible for send it out in space, and then we take it back out of space, convert it to the receiving IQ data. Then we verify the performance of our algorithm on our familiar software. There is this verification result. And that's what makes this more feasible than purely theoretical simulations. So where are we headed? That is, our USRP is mainly used in the current scientific research work is data collection, signal generation, and algorithm verification.